Okay, so today we will start the second book also. Before going to second book, I'll just give the approximate marks, not the exact marks for every chapter. Approximately I will give. Okay, for straight line, approximately 4 including the choices. Okay. Again, when you count it, it won't become 70. It may become more than 80. Okay. So don't go that way. Internal choices included. So straight line, approximately 4. Note it down somewhere, please. Then planes, motion in a plane, it will be around 10 marks. Loss of motion around 3 marks. Then work energy power 4 marks. Gravitation around 6 marks. Motion of a rotational motion in system of particles approximately 5 marks. And properties of solids, it can be approximately 8 marks. And fluids also 8 to 9 marks. Both solids also you can take it up to 9 to 8 to 9, and some fluids also 8 to 9. And thermal properties of solids approximately 5. Thermal properties of matter. And thermodynamics also 4. Kinetic theory, it may be 6. Oscillations 5 to 6. And waves also 5 to 6. So this is the chapter wise. Okay. Because, there will be internal choices also, including those choices. I have given that idea. Now, I will go with the second part of the book. Solids. What type of questions we can expect? Okay. So next is mechanical properties of solids. So there are around, I think, 7 lessons: solids, liquids, thermodynamics 3 lessons, and oscillations and waves 2 lessons. So 2 plus 2 plus 3, 4, 7. 7 lessons are there. Okay. So here we'll start with solids. Uh, One second. So you know what is ratios? Young's modulus, bulk modulus, rigidity modulus. Okay, and then comes Poisson's ratio. Learn this one. Okay, Poisson's ratio. What are the definitions of this one? Learn this. Okay, and also next one. So what happened? Okay, one second. So in properties of solids, so we need to try this question. Okay, extension and length. You did that experiment, right? The experiment you did, right?
Which experiment, sir?
The no spring experiment. Remember?
Yeah, helical spring.
Helical spring. Yeah, exactly. Helical spring experiment. In helical spring experiment, you'll have L. First, L1 is initial length, and L2 is the final length after when the load is applied. So we have delta L is equal to what? L2 minus L1, right? Delta L is equal to L2 minus L1, and we have the cross section area also. Okay, we have the cross section area. Now, what happens here? When force is applied, when F is applied on a wire or on a spring, whatever it is, whether you take a spring or whether you take a wire. So, how is the length proportional to cross section? As the length increases, does area increase or decrease?
Increase.
Hmm? Area increases or area decreases? That there's a
Area.
proportionality.
I think area
So
also increases because
just
then
go to
same.
Just go to
Is
Young's modulus.
length.
Young's modulus, what is that? Force per
F
unit length.
by L into L by delta L.
Very good. So the formula is of what? F into delta L divided by
F into delta L by A into L.
A into A. Okay, so that way you have to solve. Okay, the Young's modulus. Proportionality, just see. Okay, next one. What concept is there? So you must see this stress strain wire of a metal stress strain graph, stress strain, stress strain graph of a metallic wire. There is a experiment in that metallic wire, stress strain graph of a metallic wire. You know,
Sir, can they ask us to draw the graph for something like a rubber band and stuff?
or something like that. Okay, suppose if you take a graph, something like this, something like this. Okay, this is strain and this is stress, yeah, stress, and this is strain. Epsilon, stress and strain. So, in those
So there will
graphs,
be case study.
so there is one graph for a metallic wire, right?
Yeah. Huh?
There is one graph for a metallic wire and one graph for a rubber band. You know, rubber band.
Yes.
Yeah.
Okay, rubber band. So go through those graphs. Okay, those two graphs are important. Okay, learn that one. Next one. So so what happens? See, you have here three types of stress. What are the three types of stress and three types of strain? What are the three types of stress and three types of strain?
Three types of stress is longitudinal stress
Yeah, longitudinal stress, lo-
and
uh, normal stress, and shearing stress.
tensile stress.
The first is longitudinal stress, second one is normal stress, third one is shearing stress. And
And
in strain also we have three types of strain: longitudinal strain, volume strain, and shearing strain. Okay, or
shearing
tangential
stress.
strain. Okay, these are the three of them. Okay, so in which of them there will be like change of length, there will be change of shape, there will be change of something. Okay, so that you have to see. Is that clear?
Yes,
Suppose
sir.
if you take longitudinal stress or longitudinal strain, there will be change in the length. If there is a volume strain, there will be change in the volume. If you take shearing stress and shearing that one, there is change in the shape, right? You apply the force on the surface of the body, and the the entire shape of the body will change. Is it not?
Yes, sir.
Yeah. So that way it is. Okay. So just go through that one also. Now, next is so one more question we will see, or one more type of thing. Suppose there is a
Yes, sir.
there is a steel wire. Okay, there is a steel wire. To take a steel wire, there will be a length. Length will be given to you. Radius of cross section will be given to you, and the tension is given to you. Okay, the tension is also given to you. So what will be the stretch? What will be delta L in the wire? You understood? Suppose, yeah, there a body. Suppose there is a car is pulling the wire. Okay, just whose length is given, whose radius of cross section is given, and tension is given in the wire. Then what will be the change in length? How will you find out this?
So can you repeat the question, sir?
Yes,
Now,
sir. Can you
length
question?
is given, radius is given, tension is given. Tension means force, man. Force is given. Okay,
Yes, sir.
what will be the change in the length? Think that Young's modulus is also given to you. So use this formula and solve the problem. Is that clear?
Yes, sir.
Hmm. Next one. Yeah. So we will go with the. So this is what is important here. You can just go through the graph, stress strain graph of metallic wire. You can go through the Young's modulus numerical. Definitely one numerical will be there, and the dependence. Okay, about stress, three types of stress and three types of strain. Okay, that you see, and also you have to see these types three modulus and the ratio, Poisson ratio. Is that clear?
Okay, sir.
Okay,
So can we
then
expect questions from the revision worksheet that you gave, sir?
yeah, you can expect no problem. You can expect the
So
questions from
like,
there.
sir, if you are learning only all that revision worksheet, like, can we score good?
Yeah, yeah. Just through my just listen the videos whatever yesterday's the day before yesterday's class and today's. You just go through once again and practice the
Yeah.
worksheet. That's enough, I think. More than enough.
On,
Okay.
yeah, the revision worksheet will cover 7 chapters. So like,
I think I
the
have given the. It's only seven or not? Before that, I think we have given
no,
no.
no, 7 chap. Yeah, the new 7 chapters: thermal
I have already
properties,
given my.
kinetic theory.
Yeah, just go through once. Okay.
Yeah, yeah. Okay, sir.
So
Actually,
for
yesterday
which
I
lesson
couldn't
did you
take.
have the
There was a
PhD?
CBSE board exam. After that, we went to
Yeah,
consulate to get the papers
yes,
and
sir.
all. And by the time we came here, it was late. And after that, iftar and Taraweeh and all. So
Okay.
Sir,
okay,
for
now
case study, which lesson is it coming?
a case study. I can't say that, but see, there's a possibility here. See, case study can be from solids. It can be from kinetic theory, or it can be from fluids or thermal properties of matter. These four lessons. Clear? Thermal properties of matter, fluids, and two more lessons. Fluids and kinetic theory. Okay, just go through this one. Now we will start with the fluids chapter. Okay, so in
Yeah.
mechanical properties of fluids, mechanical properties of in mechanical properties of fluids, we'll discuss that now. Yeah, you must study about the laminar flow, turbulent flow. Okay, you must study about laminar flow, turbulent flow. I'll write here. What is laminar flow? What is turbulent flow? You must study about terminal velocity. Already I told you before also. Terminal velocity that is important. And next you need to discuss about learn about capillarity, capillary action. What is capillary action? Okay, these four things you need to study. Okay, and
Yes, sir.
so fluids. Yeah, and after that you need to study about Bernoulli's theorem. Okay, Bernoulli state and prove Bernoulli's theorem. That is important. State and prove Bernoulli's theorem. You must study this one. Okay.
In thermodynamic process,
Now let me
when
finish up.
constant,
Let me finish
okay,
up chapter by chapter. Okay. Again, I may miss out something. Okay.
okay, sir.
When it comes, just write it and keep it somewhere. I'll ask. You can ask me when the chapter is going on. Now, state and prove Bernoulli's Bernoulli's theorem. This you need to see. Okay, this is important. And also, yeah, one more thing is, application of Bernoulli theorem, man. Applications of Bernoulli's theorem. Applications. What is that? In simple words, when pressure is high, velocity is low. When pressure is low, velocity is high. This you keep this in the mind. Okay, these two things. This is the basic principle of Bernoulli's theorem. Now we will see.
Pressure is high. So it's not
Huh?
clear. Pressure is high then. Applications are pressure is high.
I am not getting what you are saying.
So I can't see the after state and prove. Yeah, it's not.
We are not able to see.
Yeah, it's not clear. Applications P increases then.
When pressure increases, velocity decreases.
Yeah.
When pressure decreases, velocity increases.
Yeah.
You do one thing, just leave the meeting and join again. It may be some issue. Okay, connecting issue. Okay, so now learn this one. So I think one more we will see. That is about terminal velocity. So the terminal velocity, what is our formula? V is equal to 2 by 9 g r square rho minus sigma by eta. Yeah, this is the formula. Learn this one well. We will be able to do the terminal velocity. Okay. Now,
So what
one
formula is
more.
it again?
Yeah, this is terminal velocity formula. Okay.
Okay.
Learn that one. So there can be a numerical based on that. Okay. So you need to learn the concept of surface tension. Okay. Surface tension. Definition of surface tension. This is important. Okay. That surface tension phenomena. How it works. Surface tension phenomena. How it works. Okay. That you learn. Next, after that, mm, you know the Pascal's formula. You know the Pascal's. What is the Pascal's formula? What is
Yes, sir.
Pascal's formula? Any
Do
idea?
we need formula because like it's only theory? Yeah?
No, there's a formula. No, F1 by A1 is equal to F2 by
F2
A2.
by 8.
Remember this one.
Yeah.
Remember this one. F1 by A1 equal to learn. There will be you learn the numerical based on this. Okay. Learn
Okay,
the
sir.
numerical based on F1 by A1 equal to F2 by A2. Is that clear? Pascal's law. Okay, this is basically the Pascal's law. Now, also now you need to learn this man. Okay, Stokes law, terminal velocity. Yeah, Stokes law, derivation of Stokes law, and terminal velocity. Very, very important. Terminal velocity. Okay, Stokes law, terminal velocity is important. And then you must learn this also, man. You know, we studied about soap bubble. Uh, what is that? The three cases we studied, no? Soap bubble floating
Yeah.
in a water drop. Yeah, water drop.
Okay, so water drop, then
Yeah, once. So, you know, there are three cases. That is, what is that? Soap bubble floating in air, soap bubble floating in air, and then what is that? Liquid drop, and three cases, no man. Water drop, water drop, soap bubble, water drop, soap bubble, and what is the third one? What happened? Forgot. Water drop is there, soap bubble, and soap bubble floating in air, and air bubble floating in water. You remember these three cases? Water drop, soap bubble, air bubble floating in water, soap bubble floating in air, water drop. Is it clear? Is it clear? What is the formula?
Yes,
P
sir.
is
Yes,
equal
sir.
to P is equal to 2T by R or 2S by R, something like that. 2S by R, 4S by R. You remember that one? What is
That's
answering? Do you remember that one formula? P is equal to 2S by R, P is
yeah.
equal
Yeah.
to 4S by R. Learn that for
Yes,
that
yes.
those formulas. Okay, those three only. No derivations not required. Learn only the formulas. Okay, is that clear?
Yes, sir.
Yes,
Okay,
sir.
Yes, sir. Yes, sir.
so that we have done. Excess pressure, Bernoulli's theorem. Already we have seen that one. And in Bernoulli's theorem, okay, one more thing. Bernoulli's theorem, you need to learn the numerical also, man. P plus half rho v square plus rho gh equal to constant. Okay, that you see. Okay, that you see. And the second one is what? A1 v1 is equal to A2 v2. What is this A1 v1 equal to A2 v2? What formula is this? A1 v1 is equal to A2 v2. Equation of
Yes, sir.
continuity. Okay,
Continuity.
equation of continuity. Go through this one also. These two numericals you can expect. Okay. Anyways, there is a derivation on this one. There is a derivation on this one, and numerical on this one. Is it clear?
Yes,
Check
sir.
that once carefully. Okay. So going to the next lesson now. Thermal properties of matter. Okay. Next is thermal properties of matter. So in thermal properties of matter, we will start with, we discussed about black body radiation. There are three scientists who are involved in that radiation. Who are the three scientists? One was Wien, one was Kirchhoff, and one was Stephen. Okay, Stephen's law. Okay, these three are there. So Wien's law of displacement. Here, Wien's law of displacement, Stephen's law. There are three laws. So in that one, only learn the formula, man. The formulas of these three. Is it clear? How that? And because why to learn that one? We need to see the dependence of one physical quantity over other. We need to learn the dependence of one quantity over the other. That is about these three fellows. Next, after that, here, there is a rod. So here there is a rod. Okay, there is a rod between two supports, two rigid supports. Now what happens is we are taking material of this material is of made up of two, half of that and half of that. Maybe a half of that is having a thermal conductivity. The thermal conductivity is maybe 2K, and this may be 5K. Something we don't know. You know what is thermal conductivity? Any idea? What is thermal conductivity?
Sir, conduction of heat like that.
I give again one example. You remember? Suppose you take a metal chair and you keep a metal chair and a wooden chair in the room, cold room. Which will be more colder? The
Metal
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 chair.
one,
chair.
metal one. And at the same two chairs, take it in the hot sun. Which will be more hotter?
Metal
Metal.
chair.
Metal chair. So what is the property which makes it faster, heating faster or
Thermal
cooling faster?
conductivity.
That property is known as thermal conductivity. So based on thermal conductivity, there is formula. There is a formula for thermal conductivity. Okay. There is formula for thermal conductivity. Learn the formula. Okay. Learn the formula on thermal conductivity. It's important. Is it clear?
Sir, what is
Yeah.
that 2K, 5K something in between? What is that?
This is thermal. K is the thermal conductivity. Think that this is made up of wood and this is made up of some material and this is made up of some material. When you heat it, what will happen? This may heat faster and this may heat slower, and this may increase more and this may increase less. Expansion will be less. You got my point?
Yes.
No, that is the way. Okay. So you try that now. Now there is yeah. So we need to find out one more case. Discuss one more case. You know, in conduction, we studied about heat flow. In heat flow, we studied about conduction, convection, and radiation. Remember? Conduction, convection, and radiation. Radiation already we discussed. Okay. Radiation already we have discussed here. Convection, we have heat flow in liquids. This is in solids. Liquids and gases is convection. Here we have one example is sea breeze and land breeze. Remember? Land breeze and sea breeze. Remember? Conduction, convection, radiation. Radiation we have seen here. Convection takes place in liquids and gases. So conduction takes place in solids. So learn what is sea breeze and land breeze. Is that clear?
Yes, sir.
Is it clear, sir? Yeah.
Yes, sir. Yes, sir. Yes, sir.
Yeah. Next, going to the next one. Next concept. Here. In thermal properties, one more question is there, man. One more type of question. That is based on specific heat capacity, man. Specific heat capacity. Q is equal to mc delta T. Yeah, remember? Q is equal to mc delta T. This is specific heat capacity. Is that clear?
Yes.
Yeah. So this one you learn. There will be a numerical. There will be a numerical based on this one. Learn the specific heat capacity. Okay. This is one way to complete. And after that, yeah. So we will go to the next one, thermodynamics now. Clear? Next lesson. Next lesson, thermodynamics. In thermodynamics, isothermal process, adiabatic process, derivation, work done by isothermal process and adiabatic process. This is important, man. This we must learn. Work done by isothermal process and adiabatic process. That you must learn, and yeah, work done by isothermal adiabatic process. Only those two are important, man, in that. And so isothermal expansion of ideal gas and adiabatic expansion of adiabatic gas. Adiabatic isothermal expansion and adiabatic expansion of an ideal gas. That you learn. Isothermal and adiabatic expansion of ideal gas. Connect it with the ideal gas and learn that one. I think that is enough for this lesson. Okay. Next one. After that, we'll go to the next lesson, that is kinetic theory. Kinetic theory. In kinetic theory, yeah. So you must learn assumptions of kinetic theory, man. Assumptions of kinetic theory of gases that you learn, and you must learn the relation between that is relation between pressure and RMS, VRMS. Relation between pressure and RMS velocity. Pressure and RMS velocity that you must learn. And what else is there? Yeah. And learn degrees of freedom, man. I think degrees of freedom you must have learned. Yeah. What are in thermodynamics, you can also learn what are state variables. Yeah. What are state variables? Learn that one. And then
In thermodynamics, so when you said isothermal and adiabatic process of ideal gas, just the definition is enough?
no derivation of these two both, and also connect this processes with ideal gas. Okay. Connect
Okay, sir.
isothermal adiabatic with the ideal gas. Okay, that is important. Next one
Okay.
is after that we have degrees of freedom. Degrees of freedom. We learned this one. Degrees of freedom. In that we have monoatomic, diatomic. Remember mono, then diatomic. In di we have homo and hetero. Please learn this one. What are the degrees of freedom for these three? That is important.
Sir,
Next,
can you explain those subparts of diatomic? I don't know
diatomic.
what is
Yeah, 3 degrees of
what.
freedom, and in homo means H2 molecules or O2 molecules. How many degrees of freedom? It has first vibratory, then rotatory, and then first translatory. How many?
5.
Homo it will be 5. Rotational will be there. It can move along x-axis, y-axis, z-axis. That is 3. And then 3 plus, and rotational, clockwise, anti-clockwise 2. Rigid, if rigid diatomic. Okay. And again in that we have rigid diatomic, non-rigid diatomic. Rigid and non-rigid. If you are taking HCl like that, this is NaCl or HCl. Again, they're also same. Three, that is three. That is, it can move along 3 different axes, and then that is vibratory, rotatory, and then translatory. Okay, so that you learn. Already I have given in this book. This I have explained in the class. These two. Okay, learn that. Next one. Okay. So, active theory. What else is there? Degrees of freedom you must see. And yeah, one more concept is there, man. Here, law of equipartition of energies. Law of equipartition of energies. Law of equipartition of energies. Learn this one. In law of equipartition of energies, suppose apply it to the same again type of molecules, diatomic, triatomic, or polyatomic molecules. Apply this concept of law of equipartition on these three. Okay, mono in diatomic, diatomic rigid, diatomic non-rigid, homo and hetero, then triatomic. Triatomic